Hello everyone. Today I will be present about statement, truth table and a negation. So, what is a statement? It's a declarative sentences that is either true or false. The example of a statement is today is Monday and then number 3 is an odd integer. We can denote the statement with variable. For example, variable P and variable Q. Okay, from the statement, we can divide it into two parts, which is primitive statement and compound statement. Primitive statement, it is a statement that has subject and predicate. And then for the compound statement, it is a combination of two or more primitive statements. So, what is the functionality of the truth table? We can summarize all the possible true value of a statement. Before, if the statement is true, we can put it as 1, and if the statement is false, we can put it as 0. So, we can use the formula 2 with the power of n, where n is the number of variable. So, let's say I need to make a statement or a truth table for P, which is 2 with the power of 1 because of one variable, and then I will get 2 column. So from the column itself, I need to put the true value of 0 and 1. And then if I have, let's say, two variable P and Q, then I need to do the equation of 2 with the power of 2, that I can have the answer 4. Then I need to make 4 column to put the true value 0 and 1 in it. And negation. Okay, from the negation, we know that it is opposite from the original statement. For example, negation of a statement P denoted by P and it is not read as not P. P is true, then not P is false. Then if P is false, then P is true. Okay, from the table above, from the table here, we can see that if P is 0, then not P is 1, and then if P is 1, then not P is 0. We need to know that negation has the opposite value from the original statement.
So today I will present disjunction and conjunction for our group presentation about logical connectives. So disjunction is used to combine two primary statements using words or to form a compound statement. The disjunction of two statements P and Q are denoted by P or Q using the symbol V. And the true value for disjunction are based on the truth table. If P or Q have the values of 1, then the values will be P or Q will be 1. Next, conjunction are used to combine two primary statements using words and to form a compound statement. For the example, P, I play guitar. Q, I study logical connectives. So P and Q, I play guitar and study logical connectives. And the true value for conjunction and are based on the truth table. If P or Q have the value of 0, then P multiplied by Q will be 0. But if the both values P and Q have 1, then the values for P and Q is 1.
So I will present about conditional statement and biconditional statement. So what is conditional statement? Conditional statement is a compound statement of the form if P then Q, which is written symbolically as P right arrow Q, where P is called the antecedent or hypothesis and Q is called the consequence or conclusion. So we can check the truth value for the conditional if P then Q in the truth table. So if the value of P is true and Q is false, then the conditional if P then Q is false. Otherwise, if P then Q is true. So that's for the conditional statement. By conditional statement. By conditional statement is two statements to be equivalent. The symbol we use for this is equivalent, and P equivalent to Q is often read as P if and only if Q. Logically, this statement is equivalent to if P then Q and if Q then P, and means that these two statements have exactly the same values of truth tables. You can see the value for the biconditional if P if and only if Q in the truth table. The value biconditional P and only if Q satisfies the following property. If P and Q have the same true value, then the value of P if and only if Q is true. If P and Q have the opposite true value, then the value of P if and only if Q is false. So that's for the biconditional statement.
Next, I will present about tautology, contradiction, and contingency. First is tautology. What is tautology? Tautology is a statement that is always true regardless of the circumstance. The second one is contradiction. What is a contradiction? Contradiction is a statement that can never be true, or we can say that it is the negation of tautology. And the last one is contingency. Contingency happens when the true value contains both true and false. How do we prove it? We use the truth table to check whether it is tautology, contradiction, or contingency. Next is example for tautology. Let's say we have a statement P or not P and Q. We use the truth table to check it. From the table, we can see that the rightmost column is all equal to 1. So, we can conclude that the statement is tautology. Next is contradiction. Let's say we have a statement P and not P or Q. We use the truth table to check it. From the table, we can see that the rightmost column is all equal to 0. So, we can conclude that the statement is contradiction. And the last one is contingency. Let's say we have a statement not P implies Q. We use the truth table to check it. From the table, we can see that the rightmost column contains both 0 and 1 value. So, we can conclude that it is a contingency.
Assalamualaikum warahmatullahi wabarakatuh. Let's go to the example logical connective question. Convert the following compound statements into singular statements by using symbols and connectives. Although Amir is a rich boy, so write it as P. Amir is a handsome boy, write it as Q. But he is humble to everyone, so write it as R. So the answer is P and Q and R. My favorite subjects are either mathematical proving or English. So we write it as parenthesis P or Q, but not calculus. So we write it as N, not R, because not calculus. So the answer is P or Q parenthesis and not R. You will score in exam if and only if you study hard. So this is my conditional statement. So you will score in exam, write it as P, you study hard, so write it as Q. So P by conditional Q. So next question is, if P and Q implies R or S is false, find the true value of not Q implies S by conditional not R implies P. So P and Q implies R or S is false. That means P and Q is 1, R or S is 0. So P equal to 1, Q equal to 1, R equal to 0, and S equal to 0. So let's go to the question. Not Q implies S. Not Q is equal to 0 because Q equal to 1 and S equal to 0. So 0 implies 0. So we get it as 1 based on conditional statement. Not R implies P. Not R equal to 1 because R equal to 0 and P equal to 1. So 1 implies 1 equal to 1 based on conditional statement. So the answer is not Q implies S equal to 1 by conditional not R implies P equal to 1. So we get it as one or true based on biconditional statement. Yeah, one biconditional, one. Next question. Construct a truth table to determine whether the following statement is tautology, contradiction, or contingency. P or not, parenthesis Q and not Q. P equal to 0, Q equal to 0, not Q equal to 1, Q and not Q equal to 0, not parenthesis Q and not Q equal to 1, P or not, parenthesis Q and not Q equal to 1. P equal to 0, Q equal to 1, not Q equal to 0, Q and not Q equal to 1, not parenthesis Q and not Q equal to 1, P or not, parenthesis Q and not Q equal to 1, P equal to 0, P equal to 1, Q equal to 0, not Q equal to 1, Q and not Q equal to 0, Q parenthesis Q and not Q equal to 1, P or not parenthesis Q and not Q equal to 1. Lastly, P equal to 1, Q equal to 1, not Q equal to 0, Q and not Q equal to 0, Q parenthesis Q and not Q equal to 1, P or not parenthesis Q and not Q equal to 1. So the last column show that all of the true value is 1, means all true, then the statement is tautology.
The last one is conclusion. What we can learn from logical connective. First, we use symbols to stand for the relationship between statements. Second, connective are used in compound statement, each of which is composed of at least two simple statements. And the last one is a statement is a sentence that can be either true or false. Okay, that is all from us. Thanks for watching.